Greetings everybody. Today is our final new lesson of the exponents unit. Today we're going to be talking about zero exponents and negative exponents. And to start investigating the properties of these, we're going to look at this chart here on your screen. If you look at the left column here, you see some calculations involving base 2 and different exponents of that base 2. 2 to the 5th power is 32, 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4. What is 2 to the 1st power? 2 to the 1st power is just 2. Look at the pattern that's happening here. What's happening as we go down from 2 to the 5th to 2 to the 4th? 32 to 16, and then 16 to 8, and then 8 to 4, and then 4 to 2. What's happening every time? Do you see it? Each time we're dividing by 2. It makes sense, doesn't it? The power of 2 is going down 1 each time, so that means that our result is getting 2 times smaller. So let's continue that pattern as we go down the column here. So if 2 to the 1st was 2, 2 to the 0, what happens if we divide 2 by 2? We would just get 1. Interesting, 2 to the 0 is 1. And then what's half of 1? Half of 1 is 1 over 2. So 2 to the negative 1st power is 1 over 2. Notice the correlation and the relationship between 2 to the 1st power, 2, and 2 to the negative 1st power, which is 1 over 2. So I got a brain buster for you. What if I asked you, what's 2 to the negative 2nd power? Well, what's 2 squared? 2 squared is 4. So therefore, 2 to the negative 2nd power would be 1 over 4. Or in other words, 1 over 2 to the 2nd power. Interesting. So we could write 2 to the negative 2nd power as 1 over 2 to the 2nd power. That's how you simplify negative exponents. You write it as 1 over the same base to the positive version of the power. That's how you do it. Let's come over to this other column with base 10 and see if we see the same pattern. Quickly here we can see that just like before, every time the power of 10 goes down by 1, we divide the result by 10. It's getting 10 times smaller every time. Let's continue the pattern here with 10 to the 1st power. What's 100 divided by 10? Well, that's 10. 10 to the 1st power is 10. What's 10 divided by 10? That's just 1. So 10 to the 0 is 1. And what's 10 to the negative 1? Well, 10 to the 1st is 10. So 10 to the negative 1 would be 1 over 10 to the 1st, which is 1 over 10. What's 10 to the negative 2nd? It's going to be 1 over 10 squared, which is 1 over 100. So we've kind of talked a little bit already about the negative exponent power and how to simplify that. The other thing I want you to recognize is this right here. The other pattern I want you to recognize is this pattern right here. When you have a base of anything, any base, 2, 10, whatever it is, x, and you raise it to the 0 power, what do you get every time? You get 1. Okay, so let's fill in these blanks here. Any value raised to the power of 0 is 1. Any value raised to the 1st power is itself. You probably recognize that too. When you had 2 to the 1st power, it was just 2. 10 to the 1st power was just 10. How do you think we would simplify 4 to the 3rd power over 4 to the 3rd power? Well, think of our division properties that we've learned about. As you recall, most likely, when we divide, we keep the base, in this case 4, and we subtract the powers. 3 minus 3 is 0. 4 to the 0 power is 1. Anything to the 0 power is 1. Let's look at some more examples. The next one's similar to the one we just did, n to the 7th divided by n to the 7th. Just like this previous example, when you have a number and you divide it by itself, you always get 1, right? So we know our answer is going to be 1, but if we show our work here, n to the 7 minus 7, n to the 0, which equals 1. What about the next one here? W to the 8th, z to the 15th, divided by w to the 8th, z to the 8th. So let's separate this into 2 problems here. So first we have our w's to deal with here, and then we have our z's to deal with here. So let's simplify. W to the 8th over w to the 8th is w to the 8 minus 8, which is 0. And z to the 15th over z to the 8th is z to the 15 minus 8, which is 7. Well, w to the 0 is just 1, right? So it would just be 1 z to the 7th, or you could just say z to the 7th power. That would be your answer for that one. The w's canceled out to a 1. Interesting. Why do we call this a challenge problem? I thought anything to the 0 power was just 1. Well, it is, but look at this. You have a 5 in front here. So really, this is like 5 times x to the 0, which is the same as 5 times 1, which is 5. So your answer for that one is actually 5. Now, what if I rewrote the problem like this? What if I put the 5x in parentheses and then raised it to the 0 power? That means that my base is 5x in this case, so whatever that base is, I raise it to the 0 power, then I would get 1. Notice the difference. If I use parentheses and raise it to the 0 power, I'll get 1, but if the 5 is not contained in parentheses, it's like 5 times 1, which is 5. So in this example, again, you have a number raised to the 0 power. It doesn't matter what it is, it's going to be 1. So in summary, any value raised to the power of 0 is 1. Any value raised to the first power is itself. Let's dig a little deeper into negative exponents by looking first at 8 to the 3rd over 8 to the 5th. If I was to expand that out, it would be 8 times 8 times 8 up top, and on the bottom, there would be 5 eighths. Notice that these would cancel to a 1, and you're left with 8 times 8 on the bottom, and just really nothing up top. So you just have a 1 left up top, and on the bottom is 8 squared. Well, what did we do here? If we were to use the law of exponents here and subtract our powers and keep the base, 8 to the 3 minus 5 is 8 to the negative 2nd. Well, as you may remember from the first part of this mini lesson video, if you have 8 to the negative 2nd, you can rewrite it as 1 over 8 squared. Notice that these are the same thing, right? 8 to the negative 2nd is 1 over 8 squared. That would be your answer. Now, that could simplify to 1 over 64 because 8 squared is 64. So either one would be okay. All right, so here's our property right there. A to the negative n is 1 over a to the positive n. So in other words, your final answer should never have a negative power in it. You should always move that to the other side of the fraction to make it positive. Let's look at some examples. 3 squared over 3 to the 6th would be 3 to the negative 4th power if you do 2 minus 6, and that is the same as 1 over 3 to the positive 4th power. So that would be your answer for that one. Notice how, if you look at the original problem, there are 4 more 3's down here than there are up here, right? 6 is 4 more than 2, so it makes sense that your final answer would have something in the denominator. There's 3 additional 4's, which is 3 to the 4th power, so 1 over 3 to the 4th power is your answer. Look at the next problem. If we kind of follow that same line of thinking that we just used, there are 3 more 2's down here than there are up here, aren't there? So we're expecting to have something in the denominator. If we follow our rule, 2 to the 8 minus 11 is 2 to the negative 3rd power, which is 1 over 2 to the positive 3rd power. So that would be your answer for that one. All right, let's keep going. Let's do another one. Here we have A's and B's. We're going to split up the problem. Let's do the A's first. So A squared over a to the 4th is a to the negative 2nd power. And b to the 5th over b to the 2nd is b to the 5 minus 2, so b to the 3rd power. Notice that we have a negative power right here with the a, so we have to move that to the denominator. Right now, this is over 1. So what I need to do is I need to take this and move it to the bottom, okay? And when I do that, I get b to the 3rd still up top, and on the bottom now I have a to the positive 2nd power, and that would be your answer for that one. I'll do this one challenge problem to wrap things up, and as always, you can always look at these blank notes and a key of the notes, both available in Schoology if you want more practice problems or further work. So if I was to work on this challenge problem here, this is a power raised to a power, so this negative 2 gets applied to the 2, the x, and the y. So right now, this is a 2 to the 1st power. If I apply the negative 2nd power to it, it's 2 to the negative 2nd power, 1 times negative 2, times x to the 3 times negative 2, so that would be negative 6, times y to the negative 5 times negative 2, so that would be positive 10, y to the positive 10. All right, currently this is all over 1, and a couple of these terms I need to move to the bottom. So because these are negatives, right here, this one and this one, they need to go to the bottom. So I'm going to take this and this. They're both going to pop down and the powers will become positive. This one's going to stay put. So as I simplify, y to the 10th is still in the numerator. But in my denominator now, I have 2 to the positive 2nd power and x to the positive 6th power. See how that works? So if I simplify that a little bit more, I have y to the 10th over 4x to the 6th, because 2 squared is 4. Next, I want you to think about this question right here. This is interesting. 4 to the negative third is greater than 1, equal to 1, or less than 1. Well, when I have a negative power, remember, that goes to the denominator, and it's 1 over that number. So if I was to rewrite 4 to the negative third power, it would be 1 over 4 to the positive third power. That is 1 over 64. Okay? So is that number greater than 1? Is it equal to 1, or is it less than 1? Well, 1 over 64 is positive, so it is greater than 0, right? But it's not greater than 1 or equal to 1. It's just a little bit bigger than 0. So of the 3 options, the best one is less than 1. It's less than 1, but it's greater than 0. So when you have a negative power, it is not going to be a negative result. Some people think that, but it's not. When you have a negative power, like 4 to the negative third, it's going to be a small fraction that's just a little bit bigger than 0 and less than 1. Okay, at this point I would encourage you to pause the video and take a look at some of these mixed practice questions right here and see if you can do them as a review of some of the properties that we've been learning about. And if you want to see some possible solutions, there's many different solutions. You can check the key in Schoology. I'm going to show you a couple more examples here involving comparing expressions and getting like bases. And that's going to be it after that. And so for the first one here, compare the two values. I want to see which one's bigger, 9 to the 12th or 9 to the 36th over 3. Well, this one is fully simplified right here, but I could simplify that further, couldn't I? 9 to the 36th over 9 to the 3rd, keep the base and subtract the powers, right? So that would be 9 to the 33rd and 9 to the 12th. Which one's bigger? Well, 9 to the 33rd is much bigger. When it comes to positive powers, you're looking at these numbers right here. Whichever one's bigger is going to produce the larger result, assuming the bases are the same, okay? Let's look at some more involving like bases. Yeah, so how in the world would I compare 5 to the 28th and 25 to the 19th? How would I do that? They're not the same base. 25 and 5, I can't compare two numbers unless they have the same base. But lucky for us, we can rewrite 25 as a base 5. Isn't 25 the same as 5 squared? Oh, yeah, 5 squared is 25. So I can rewrite 25 as 5 squared and then raise that to the 19th power. And then here, this is already base 5, so I'm just going to keep it 5 to the 28th. If I simplify the right side here, 5 squared raised to the 19th, that's 5 to the 38th power. And this is 5 to the 28th power. Which one's bigger? The one with larger power. So this one would be larger. Let's do another. 3 to the 18th compared to 9 to the 10th times 3 to the 3rd. Again, we have an issue here with this base 9. We have to get it to be a 3. So think about how I can make a 9 into a base 3. I could do that by rewriting 9 as 3 squared. So I'm going to rewrite 9 as 3 squared raised to the 10th. I can do that because 3 squared is the same as 9. And then the rest, I'm just going to carry it down and keep going. This isn't going to change. The 3 to the 18th isn't going to change. 3 squared raised to the 10th power is 3 to the power raised to a power you multiply, so 3 to the 20th times 3 to the 3rd. All right, I'm almost done. 3 to the 18th, and then if I simplify the right side, I get 3 to the 20 plus 3, which is 3 to the 23rd power. Which one's bigger? The one with the larger power. 23 is bigger than 18. They both have a base 3, so the larger number will be that one. Last example here, and this one's the most challenging one. So if you want, take a pause in the video and see if you can rewrite these 3 terms with a base 3. We always go to the lowest power. So the 3 is the lowest power here. And so the challenge here is to rewrite 9 and 27 as the lowest power, which is 3 in this case. So how could I rewrite 27 to the 5th power? Well, 3 to the what power equals 27? 3 to the first is 3. 3 squared is 9. 3 to the third power is 27. So I'm going to rewrite 27 as 3 to the third power. And 3 squared is 9, so I'm going to rewrite 9 as 3 squared raised to the 8th power, divided by 3 to the 4th. That one doesn't change because it already has the lowest possible base of 3 that we're trying to convert all the others to. So let's continue simplifying the left side. 3 to the third raised to the 5th is 3 to the 15th power. And then on the right, we have 3 squared raised to the 8th. That's 3 to the 16th, divided by 3 to the 4th. Now, almost done. 3 to the 15th is already simplified, so we just have to continue simplifying the right side. 3 to the 16th over 3 to the 4th is 3 to the 16 minus 4, which is 12. All right, so in this case, 3 to the 15th would be larger. 15 is greater than 12, so this would be the greater number. Okay, that is it for our lesson today. Make sure you check out Schoology and do the practice in Schoology, and there's also always a blank copy of the notes and a key if you need to check anything out. Keep an eye out for a review coming later this week and a quiz over exponents coming later this week or possibly the beginning of next week. So just stay tuned, keep checking the updates, and as always, let me know if you need anything, sign up for a conference, keep it 100. Have a good one.